Hello, my name is Gian, Cedrick Epilan, BSCS284, and this is my project BioMemo. Users often face significant difficulties in recording, organizing, and revisiting biological observations because photos and species information frequently end up scattered across different platforms. BioMemo solved this problem by providing a single, seamless platform where users save key record information on their biorecords, all with the goal of making biodiversity recording cleaner, faster, and much easier to revisit. A few key features of the BioMemo app is user login, registration, and Google sign-in, capture biorecords using camera or upload, photo editing, cropping, and metadata handling, a biorecord collection and detail views, a species search or reference details, and the map view for seeing the biorecords. The app starts from a splash and login screen. Here, users can either register a new account or log in to an existing account. For demo, account is already set up, so I will use Google Sign-in to enter the app faster. After login, app redirects to the dashboard. Dashboard works as a main entry point where users can access main features like capture records, search, map, and profile. Next, I will then click on this button to add a biorecord. Here, users can capture new photos using camera or upload an existing image. Let's try selecting an image. Once selected, it then opens the photo editing flow, where users can crop or adjust the image before uploading. Once it finished processing, the screen shows the biorecord and its details. Here we can see the observation details and species-enriched data. Here we can find interesting information like taxonomy, habitat, diet, lifespan, distribution, and the conservation status. It also shows which sources the data is retrieved from. Once that is done, we can then open the biorecords page where the information is automatically updated. This page shows the saved biodiversity records. We can click on an entry to see the biorecord details. Then, I will open the species search. This lets the user search species reference information and view more details about the selected species. After that, we can then go back to the biorecords page and click on the biomap button to open the map screen. This shows records based on saved location data, helping the user see where the observations were made. Finally, we can go to the profile screen, where the account details are shown. The user can also opt to log out if needed. Here are the technologies used for this project. Android and Kotlin for the app development, XML layouts for the UI screens, the MVP pattern for the screen architecture, Supabase for authentication, database storage, and real-time features, Google Auth for sign-in, Ktor or Supabase Kotlin SDK for backend communication, OSM Droid for the map display, JUnit, and Android Test for testing. Now, for the source code structure, the project uses a vertical slicing approach. Instead of placing all the code by technical type only, project groups important parts by feature or module. For example, we have a feature folders like authentication, records, and species. Each feature contains code related to its own responsibility. Auth handles login, registration, and user logic. Records handles biorecord data, storage, and record-related use cases. Species handles species search and reference information. Inside each feature, flow usually goes from the domain logic to data implementation. Domain files define models, repositories, and use cases. Data files contain actual implementation, such as connecting to Supabase or local storage. Then, Screens folder contains UI-level features like login, register, capture, bio, search, map, and profile. These screens connect user interactions to project logic. This structure makes projects easier to maintain because each feature has clear responsibilities. I will now show the feature flow using the login as an example. This file is the view part. It displays the login screen and handles user interactions. When the user clicks the login button, login activity gets username and password from input fields and then calls presenter.onLogin clicked. This file is the logic layer. Login presenter checks if username or password is empty. If input is invalid, it tells the view to show error. If input is valid, it calls model using model.authenticate. This file connects presenter to domain logic. Login model does not directly handle the UI, it calls auth use cases, specifically sign-in logic. These files contain authentication use cases. For login, sign-in calls repository through repository.signin. This keeps business logic separate from data implementation. This file defines what authentication repository must do, like sign in, sign up, sign out, and check current user. It acts like contract for data layer. This file is the actual data implementation. It connects to the Supabase, resolves username or email sign-in, user sign-ins, and returns success or failure results. So, full feature flow is: user interacts with login activity, activity sends requests to the login presenter, presenter validates and calls login model, model calls auth use cases, use case calls auth repository, and Supabase auth repository talks to the Supabase. Then the response travels back upward. Repository returns the result, use case gives it back to the model gives it to the presenter, and presenter tells activity to show, error to navigate to the dashboard. Overall, BioMemo helps users keep biodiversity observations organized in one place. Instead of losing track of photos and species details, users can save, view, and revisit their records anytime. That is all for this app. Thank you.